In section 2.4, we're going to talk about average rate of change. You actually know average rate of change better as slope. And in Algebra 1, you probably learned slope formula. We used m for slope as y2 minus y1 over x2 minus x1. You may even have had a teacher who taught you this notation. This is the Greek letter delta. And in math, the Greek letter delta, which looks like a triangle, yes, I know, it means change or subtraction. Now, when we first were introduced to slope, it was in relation to linear equations. So you would have a line, and you get two ordered pairs on the line, and then you would plug them into this formula in order to find out how steep the line was. We don't always want to know the slope of something that's linear. Sometimes we want to know the slope of just a portion of a graph. And that's where average rate of change comes in. In the real world, we want to know how fast things change over time. So I'm going to give you another formula that's actually the same as the slope formula. It's f of x minus f of a over x minus a. The reason it's the same is because this was the function notation for y. And then the number in the parentheses is always your input x. So this is really the same as saying y2 minus y1 over x2 minus x1. So f of x and f of a are two different y coordinates, and x and a are two different x coordinates. So here's an equation of a graph that's clearly not linear, but we want to find the average rate of change between these two red dots. Now, in order to do that, we're going to find the ordered pair at each of those red dots. So this one is the ordered pair -1, 0, and this one is 5, 4. As long as you remember that in an ordered pair, the first number is x and the second number is y, we can find the average rate of change by doing y2 minus y1 over x2 minus x1. Well, what if you reverse the order? What if you start with the ordered pair down here instead, and you do 0 minus 4? That's fine as long as you're consistent. The denominator would have to be -1 minus 5. You'll get the same answer. In the first fraction, we'd get 4 over 6. Remember, those two negatives make a positive, and that reduces to 2/3. In the second one, we'd have -4 over -6, and those two negatives make a positive, and you reduce the fraction. Remember to ask yourself about the reasonableness of the answer. Look at this dashed line here. It's going up from left to right. In other words, my slope should be positive. And if it wasn't positive, then we know we made a miscalculation somewhere. What if I don't give you a graph? What if I just give you an equation and I ask you to find the average rate of change between two input values? Now, sometimes we call the input x, sometimes we call it z, sometimes we call it t. How do you know what the difference between the input and output is if I don't use x and y? Well, the number in the parentheses in function notation is always the input. And then this is always the output. Always, 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 always. So if I look at problem 11, in order to find the average rate of change, the denominator is going to be, it doesn't really matter. I can do -1 minus 4 because those are your inputs. The numerator is always the outputs. So outputs over inputs. So in the numerator, I'm going to have to plug -1 into this equation and evaluate it. Be careful when you do that. If you're going to use a calculator, you need to plug it in like this, because if you don't use parentheses, the calculator will give you the wrong answer. When you square a negative, you get a positive, and 2 times -1 is -2. So we're going to get -1. So if you plug in -1, you get out -1. And now we're going to do the same thing with 4. I'm going to plug in 4. So I have 4 squared plus 2 times 4. 16 plus 8 is 24. Remember, in the average rate of change or slope formula, they're always being subtracted. So I end up with negative 25 over negative 5. Two negatives cancel and you get positive 5. Let's try it again with number 13 here. The denominator, I can do 0 minus 10. That's fine. It just means I have to plug 0 in first. When I plug in 0, 0 cubed minus 4 times 0 squared is 0. When I plug in 10, let's erase that. When I plug in 10, I get 10 cubed minus 4 times 10 squared. So I get 1,000 minus 400, which is 600. So I'm going to get negative 600 over negative 10. The two negatives cancel, and I end up with 60. And that's the slope. Since slope or average rate of change isn't anything new, in precalculus what we really want to do is we want to focus on applications of it. So here's a nice application problem from the book. The graph shows the population P in a small industrial city from 1950 to 2000. The variable x represents the number of years since 1950. That part's really important information because you have to understand what the axes are telling you. Notice on the x-axis, and it says year. The year don't say 1950, 1960. It doesn't say that. It says that they're the years since 1950. So this 10 really represents 1960, and 20 really represents 1970. But you don't need that to find the average rate of change. The other thing I want to point out is that it says the output, what's on the y-coordinate, is the population in thousands. So this is really 50,000. This is really 40,000. But to simplify the graph, they just tell you it's in thousands. You have to multiply that number by 1,000 to get the actual value. So now we're ready to go do part A. What was the average rate of change of P between x is 20 and x is 40? So what I'm going to do is I'm going to find the ordered pair when x is 20 and the ordered pair when x is 40. So it looks like this one's at about 20, 40. And this one looks like it's at 40, 40. So the average rate of change is going to be, subtract the y's, those are those, and then subtract the x's. I'm going to get 0 over negative 20, and 0 divided by negative 20 is 0. Wait a second, why was the average rate of change 0? Well, because to go from 20 to 40, you end up with a horizontal line. And we learned in Algebra 1 that the slope of a horizontal line was 0. Now in reality, the graph is going up and down, right? It's first increasing from 0 to about 25, and then it's, let's say 0 to 25, and then it's decreasing from 25 to 50. That was called your intervals of increasing and decreasing. I also want you to notice that there appears to be a maximum here at 25, 50. But remember, that's really 50,000, and this is really 1975. It's 25 years after 1950. So in the second part where it says interpret the value of the average rate of change that you found in part A, again, because we were going from 20 to 40 years, the line that connects those two is horizontal, and the slope of a horizontal line is 0. How about if I want to find average rate of change from a table rather than a graph? So this table gives the population in a small coastal community for the period of 1997 to 2006. Figures shown are for January 1st of each year. What was the average rate of change of population between 1998 and 2001. So here's 1998, here's 2001. When you find the average rate of change, since you're using the slope formula, you need to know which one's the input and which one's the output. This is going to be your x and this is going to be your y. So we're really using the ordered pairs. 1998, 856, 2001, 1591. So I'm going to do, 1591 minus 856, and the only reason I did that is because I'll get a positive answer. But if I use that in the numerator, I have to do 2001 minus 1998 in the denominator. So that's going to be 735 in the numerator, 3 in the denominator, which is going to give you 245. Now, that's not the final answer. What does that answer mean? It means that the population was increasing at a rate of 245 people per year. That's what the answer means. Because the population's going up. How do I know it's going up? Because the slope was positive. All right, let's look at that again. But this time, let's go to part B. So in part B, we want to find the average rate of change between 2002 and 2004. Now right away, before we do any work, notice that the population went down. If the population went down, should your slope be positive or negative? Well, it should be negative. So this is an ordered pair, this is an ordered pair. So this time I'm going to do 826 minus 1483, because your y's go in the numerator, over 2004 minus 2002. So we're going to get negative 657 over 2004 minus 2002 is 2. And when you divide that, you're going to get negative 328.5. Now, here's where we have to be careful that you can't have 328.5 people. So you got to round it. So maybe we'll say that the population is decreasing at a rate of about 328 people per year. Then, the next question says, for what time period was the population increasing? So I'm going to look back at the table, and I notice that from here to here, the population increased. So it increased from 1997 to 2001. That was called an interval of increasing and decreasing. The intervals of increasing and decreasing only ever refer to the x coordinates, and this is x and this is y. And then part D says, for what time period was the population decreasing? Well, we always start at whatever the highest number is, and then it was consistently going down. So it was decreasing from 2001 until 2006. And that was average rate of change of a function, and it gave us the opportunity to do a little review of intervals of increasing and decreasing.